China's scientists may have just unlocked the battery breakthrough the world has waited decades for. A solid-state design promising over 1,000 kilometers on a single charge, greater safety, and a huge leap in durability. This discovery could redefine electric transportation and push traditional engines toward the past. In this video, we'll uncover how this technology works and what this breakthrough could mean for the future of energy and mobility. The core breakthrough in this new battery development begins with solving one of the biggest engineering challenges in solid-state technology, creating a flawless contact surface between the solid electrolyte and the lithium metal anode. This has held back solid-state batteries for years because the materials behave so differently. The commonly used sulfide-based electrolyte is extremely hard and brittle, almost ceramic-like. In contrast, the lithium metal anode is soft and malleable, almost like modeling clay. Pressing these two materials together creates a surface filled with tiny gaps, irregularities, and micropockets that disrupt the movement of lithium ions. These irregularities increase resistance, slow down charging, reduce efficiency, and limit the battery's overall potential. Chinese researchers at the Institute of Physics under the Chinese Academy of Sciences introduced a solution that transformed this uneven surface into a seamless interface. Their innovation uses iodine-ions that behave like a self-moving glue. When the battery operates, the iodine ions automatically migrate toward areas where small gaps exist. Instead of remaining scattered throughout the electrolyte, the ions concentrate at the interface, pulling lithium ions with them and filling in every tiny pore or imperfection. This iodine-ion mechanism doesn't just smooth the surface, it improves ion transport, stabilizes the lithium metal anode, and ensures consistent performance over time. It resolves a bottleneck that has limited solid-state batteries from achieving long-range capability. With this interface problem addressed, the battery can now function with the high-energy lithium metal anode while maintaining a dependable solid electrolyte structure. Once the interface challenge was resolved, Chinese research groups shifted focus to making the battery capable of delivering long-distance performance while maintaining flexibility and stability. A major step came from the Institute of Metals under the Chinese Academy of Sciences, where scientists engineered a polymer-based electrolyte framework. This design behaves like a resilient skeleton that allows the solid electrolyte to stretch, bend, and twist without cracking. Traditional solid electrolytes can fail when exposed to everyday vibrations or pressure changes. But this new structure endured over 20,000 bending cycles in laboratory tests, proving it can withstand real driving conditions. Within this flexible framework, the researchers embedded microscopic chemical modules, each with a specific job. Some modules accelerate the flow of lithium ions, making it easier for the battery to charge and discharge efficiently. Others capture excess ions, preventing unwanted buildup that could reduce performance over time. This precise chemical engineering produced a significant 86% increase in energy storage capacity, a meaningful improvement that pushes the battery's theoretical range beyond 1,000 kilometers on a single charge, far above the typical 500 kilometer ceiling of most current EVs. To enhance safety and support high-voltage operation, a separate research team at Tsinghua University modified the electrolyte using fluorinated polyethers. Fluorine is known for its strong resistance to electrical and thermal stress. When integrated into the electrolyte, it forms a protective shell that keeps the material from degrading at high voltage. With the scientific challenges addressed and performance validated, the broader impact of this breakthrough becomes clearer. A solid-state battery capable of exceeding 1,000 kilometers per charge fundamentally shifts how people view electric vehicles. Drivers often worry about running out of power on long trips, a concern called range anxiety. If one full charge offers more distance than many gasoline cars can cover, typically 600 to 800 kilometers, that concern disappears. For example, a 1,000-kilometer range makes it possible to travel from Shenzhen to Changsha, from Paris to Milan, or even complete a round trip between Los Angeles and San Francisco without recharging. This transforms electric vehicles from convenient city options into truly long-distance solutions. The impact extends beyond personal transportation. Solid-state batteries with high energy density and enhanced safety could support emerging technologies such as low-altitude aerial mobility, autonomous delivery platforms, and long-duration robotics. Because these batteries are non-flammable and more thermally stable than liquid electrolyte versions, they offer greater reliability for aviation-grade applications and high-performance industrial systems. In the automotive industry, these advancements may reshape global competition. China already leads in EV manufacturing and battery production, and this solid-state progress strengthens that position. If these designs move into mass production, manufacturers could integrate lighter, more efficient, and longer-lasting battery packs into future models. This new solid-state battery isn't just an incremental upgrade, it's potentially a leap. By solving the interface problem, designing flexible and high-density electrolytes, and building production lines ready for real cars, China may have unlocked the key to a true 1000 km plus EV era. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration, and don't forget to leave a comment below. Thank you for watching, and see you next time.